Hello everyone. Today we're going to do a little refresher on some of the basics of Unit 8 Thermochemistry. So to start things off, what is thermochemistry? Thermochemistry is the study of heat energy associated with chemical reactions and/or physical transformations. In thermochemistry, heat is represented by Q, is measured in joules, J. Form of energy always flows from a warmer object to a cooler object. Heat, also known as enthalpy, change is represented by delta H, which is the amount of energy in heat released or absorbed during a process. Also, a reaction may release or absorb energy, and a phase change may do the same, such as in melting and in boiling. Two important processes include the exothermic process, which is energy that is given off, or energy that exits, and the endothermic process, which involves energy being taken in, or energy that enters the reaction. Also, please note that with exothermic reactions, heat is being released, and that with endothermic reactions, heat is absorbed. And a little trick that I use to remember that is if it's exothermic, heat is exiting. And for endothermic, if you can remember the first one, then you'll be good because it's the opposite. Some other important things to know would be the heat of vaporization and the heat of fusion. Heat of vaporization is the heat required to vaporize 1 mole of substance. And this is shown in the process of transferring from a liquid to a gas, and through this, heat is absorbed. So that's plus delta H. And for a gas to liquid, heat is being released. That is minus delta H. With heat of fusion is the heat required to melt 1 mole of solid substance. And this is shown as the transition from solid to liquid, and through that, heat is absorbed. So that would be your plus delta H. And if you're transferring from a liquid to a solid, heat is released, and that'll be shown as negative delta H. Next, we will be going over specific heat, also known as the specific heat capacity. Specific heat capacity, shown as C, is the amount of heat required to raise 1 gram of a substance 1 degree Celsius, or J/G degrees Celsius. While often differing, every substance has a specific heat. An example of this can be created when comparing water to steel. Under the same conditions, steel heats up faster than water, which means that water has a higher specific heat. If a material has a higher specific heat, it will take more joules of heat to increase the temperature of that substance. With that said, metals usually have a lower specific heat when compared to other substances. Now, for an equation. We'll be doing the specific heat equation to be specific, and this will be shown as Q equals mc delta T. And heat equals mass times specific heat times change in temperature is what that means. Also, delta T equals TF minus TI. And what this means is T final temp minus T initial temp. Q equals the heat energy measured in joules, J. M is the mass of a substance, kg, kilograms. C equals the specific heat, and that is measured in units, J/kg times K. Triangle, also known as delta, that's what it's called, is a symbol meaning the change in. Delta T equals the change in temperature, and the temperature is measured in kelvins, K. To use this equation, you will see a problem that looks probably like this or similar. If the temperature of ethanol, mass of 34.4 grams, is increased from 25.0 degrees Celsius to 78.8 degrees Celsius, how much heat has been absorbed by the ethanol? Specific heat of ethanol is 2.44 J/G degrees Celsius. Now, to solve this equation, I'll be breaking it up into 2 steps. So for step 1, we'll be setting up each variable. M, which is our mass, is our 34.4 grams. Delta T is 78.8, minus the 25 because you do the final temperature minus the initial temperature. C will equal 2.44 J over G degrees Celsius, and Q is what we will be solving for, and so that'll be a mystery for now. Step 2 will be setting up our equation, so we'll go Q equals 34.4 G, and then close parentheses, more parentheses, 2.44 J over G, closed parentheses, more parentheses, 78.8 degrees Celsius minus 25.0 degrees Celsius. And you plug that all into your calculator, and for a final answer, you should get Q equals 4,515.76 joules. Now, to wrap things up, we'll be going over heat/enthalpy and some of the laws and rules that come with it. Now, it's been a hot minute since we've done Unit 8, so you probably forgot what enthalpy is. Enthalpy is when a substance changes at a constant pressure, the enthalpy tells how much heat and work was added or removed from the substance. While enthalpy is similar to energy, it is not the same, though, so that is always something to keep in mind. Hess's law. 2 or more thermochemical equations that can be added together to produce a final equation for a reaction. The sum of the individual enthalpies is the overall enthalpy for the reaction. Some final things just to keep in the back of your head is if the delta H is negative, then an exothermic reaction has occurred. H, which is enthalpy, of reactants was higher than the H of products. Also, if the delta H is positive, then an endothermic reaction has occurred. So that would mean the H of reactants was lower than the H of products. So I hope you guys got all that you needed out of this video. Thank you all for watching. I hope you all learned a lot, and I really hope we all do well on this final. Yeah, I do. A lot.